So this section is on properties of logarithms. We're going to learn about using properties of logarithms to expand and condense logarithmic expressions. And we're going to evaluate logarithmic expressions whose base is not 10 or e. So here are the properties of logarithms. So we have log of any base. When I have multiplication inside, that means I add the logs. I can expand it by adding log a of m plus log a of n. Now that makes sense because remember, logs and exponents kind of go together. If we remember some properties of exponents, when I multiply, I add the exponents. So that's why when I multiply here, I add the exponents. Think of it that way, because remember, logs are like exponents. Answers to logs are exponents. Same thing with division. When I divide, I subtract. Now notice that I have n in the bottom. So when I subtract, n has to be the one being subtracted. Okay, m's on top, so m is positive, n is on the bottom, so n is negative. Here we have log a of m to the k power. So when I have a power, I can bring the power to the front, so I can multiply that k to the front. So remember, once again, when I have a power on the outside, I multiply. So that's why properties of powers. So there, I just can bring that k out in front. And remember, log anything to the first power. Remember, that's exponents. Anything to the first power is itself. So log a of a is 1 because the exponent has to be 1. And here we see that the log and the exponent, since the base is the same, the log and the exponents cancel each other out. Same thing for this one. The base is the same, so the log and the exponent cancel each other out, and that leaves you with k. The log and the exponent cancel each other out. And then here, so what exponent would you have to have for a? If you had an exponent of 0, what would it have to be? So 1. So any log of any base of 1 is 0 because anything to the 0 power is 1. Now, this down here is the change base theorem. The change base theorem, so I have some base, and your calculator only uses base 10 and base e. So if you're using some other base, you got to use the change base theorem to be able to use your calculator. So we're going to use a change base theorem. So here I can use my calculator if I use base 10 or base e. It doesn't matter which. But if you're changing it for some other base, it doesn't matter which. Whatever base you want it to change it to, you can change it to that base. So I have log base b of m. So I have log of some other base of m over log of some other base of b. And that it will give you the change base. Okay, so you're just changing base. And we do that using, if we're trying to find some other log other than base 10 and e, because that's all the calculator will do for you is 10 and e. So here we want to change it to some other base. Here for the natural logarithms, notice they're exactly the same. Natural logarithm is just base e. So if, here it's the exact same stuff. So everything's the same. When you multiply, you add. When you divide, you subtract. When you have power, you bring the power out in front. And the natural log and the e cancel each other out, leaves you with 1. Okay, it doesn't leave you with a 0, leaves you with 1. Here, the natural log and the e cancel each other out, leaves you with k, whatever the power is. You know, you can assume the power here is 1, so that's why that's a 1 there. The natural log of 1, remember, any log base of 1 is going to be 0. and then the change base theorem. So I can use natural log for the change base theorem. I like using natural log of change base theorem because it's one less letter to write when doing it. So here's the change base theorem for natural log, and here's the change base. You can change it to log base 10. It's just change base theorem. Here I want to introduce fractional exponents. You should have learned this back in algebra because they did teach you fractional exponents in algebra. You kind of hit it again in algebra 2, but we tend to forget it. So I want to go over the fractional exponents. So the square root is x to the 1/2 power. So I can change it to a fractional exponent. And cube root to the 1/3 power, and so forth. The fourth root to the 1/4 power. I can also have powers under the root. So the power is on top, the root is on the bottom. So that is a square root, so that's a 2 on the bottom. Here, the power is on top, the root is on the bottom. So the root is always going to be on the bottom with these fractional exponents. So you need to kind of know that. So when we do some problems here, we're going to be changing the root problems into fractional exponents. So that should go seamless. It's not that hard. So here's one, and see we're doing this problem where we have a cube root. So we're going to have to change that into a fractional exponent. But first, let's use properties of powers. Something I notice here, I have multiplication right in here. So I have multiplication. So therefore, whenever I have multiplication, that means I can add. So that means I can split it up and add. So I expand it and split it up and add. Now I have this cube root, and I can't really do anything with roots, but I can do things with powers. So I'm going to change this into the cube root into the 1/3 power. Now the x minus 1 is all to the 1/3 power, so it needs to be in parentheses. Now that I have powers, I can use another property of logarithms by taking the power and bring it to the front. So I take that power and I bring it to the front. So there we go. There it is expanded. So that's how I use the properties. That's all expanded. Here I have division. So with division, I subtract. So I can subtract. Remember, the denominator is what's being subtracted. So whatever's in the denominator, that is the subtraction. Now I have some other things. I have powers. Well, I take that power of 4 and I bring it out front. I bring the power of 2 and I bring it out front. I can't do anything with the x squared plus 3 on the inside of the parentheses. I just got to keep it inside parentheses. So that is as far as I can expand it. If I have plus or minus inside parentheses with these logs, I can't do anything with it. I just, there are no properties with plus or minus on the inside, only multiplication, division, and only with powers. If I have plus and minus on the inside of a log, I can't do anything with it. So I just, right there is my final answer to expand it all the way. Now here's a combination. I'm doing some multiplication on top. I see some multiplication on top. I have some division on the bottom. So I got a little bit of both going on. So let's first, we have division. So that means I subtract. So I subtract that x plus 1 quantity squared. But then I also have multiplication. So that means I can expand that and make that plus. And then I also did, remember I have that root, and I changed the root to the 1/2 power. So I changed the root to that 1/2 power. Now I have powers, so I can do something with the powers. I can bring those powers out in the front, bring the power out in front, bring the power out in front. And there it is, all expanded. Now, from what we've done so far, I want you to try this on your own. I'm going to pause it. I want you to try it. I'm going to go over it and give you the answers, but I want you to try it, see if there's anything that you did wrong. If there is, and you don't understand after I've went through it, then ask that question in class. So here I have ln of 3 to the 2x. So I have a power, so I can take that power and bring it out in front. So I can make that ln, well, I have the 2x in the front, ln of 3. Remember, ln is that natural log. Ln is base e. So the 2x is out in front. So here I have multiplication. So I have multiplication here, and I have a little power. So multiplication first. So I'm going to first expand it. So I'm going to expand it to ln of x plus ln e cubed. Now I have another property. The ln and the e, well, they cancel each other out. The ln and the e cancel each other out because ln, remember, is log base e. So the ln and the e cancel each other out, and that just leaves me with 3. So that gives me ln of x plus 3. Now, on number 3, I need to get rid of that root and make it a fractional exponent, but there's already a power in there. Remember, the root is the denominator, the power is the numerator. So I'm going to rewrite it. ln of x to the power of 5 halves. So it's a 5 halves power. Now I can take that power and I can move that power to the front. So it's going to be 5 halves ln of x. Once again, for number 4, I need to make that root a fractional exponent, but the whole x minus 1 is under the root. So I need to write that inside parentheses. It's supposed to be 1/2. So now I can take that power, and I can take that power and bring it out front, and that gives me 1/2 ln of x minus 1. Remember, I can't do anything with plus or minus inside the parentheses where the ln is, or any log. I just have to leave it the way it is. Number 5. Number 5 is a bunch of multiplication. Well, multiplication, all I have to do is add. So I just add a bunch of times. So that's going to be ln of x plus ln of y plus ln of z. Now, number 6, I have division on the inside, and I have this power of 2. Well, that squared goes for both things on the inside. So I can actually kind of rewrite this using my properties of exponents. I can do ln of x plus 2 squared over x plus 5 squared. So now I have division, so I can subtract. So ln of x plus 2 squared minus ln of x plus 5 squared. Now I have powers on the outside, so I can take those powers and I can bring them out in front. So that gives me 2 ln of x plus 2 minus 2 ln of x plus 5. So that one. So now we've expanded. Now we're going to condense. So let's condense this. We have a number being multiplied. So before, remember when we were expanding, I had a power and I brought it out in front. So if I have a number in front, I can make that into a power. If I have a number in front, I can make that into a power. So let's do that. So I have ln of 2 cubed plus ln of x squared. Now I have addition. Now that I have addition, remember when we multiplied, we added. So if we're adding, we're going to multiply. So we're condensing. And remember, 2 cubed is 8. So there's that. That's why it's 8, not 2 cubed. 2 cubed is 8. Letter B. Once again, I have the 1/2 power in front, so I need to make it into a power. So that 1/2 is in front is now going to be a power. The 2 in the front, it's going to now be a power when I'm condensing. So I have 4 to the 1/2 minus log a 5 squared. So I have now they have powers. Well, 4 to the 1/2 power, that's the square root of 4, so that's going to be 2. And 5 squared is 25. And it's subtraction, so it's going to be division. So because I have subtraction, there's division. That's why it's 2 over 25. Letter C. Well, let's look at what's going on here. I have a minus. I have a minus 2 here. I have a minus log, and I know minus means division. Plus means multiplication. Well, think of it more this way. Think of your positive stuff on top and your negative stuff on the bottom. So when you do this problem, if you think of it that way, where all your positive stuff's on the top and all your negative stuff is on the bottom, then it makes the problem a lot easier. Okay, so here I can bring that 2 and make it into a power. So that's going to be a negative log a of 3 squared plus log a of 2 cubed minus log a of x plus 1. Supposed to be plus. Now, everything that has a minus goes to the bottom. Everything that has a plus stays at the top. So therefore, I have 2 cubed on top, and 2 cubed is 8. I have 3 squared on the bottom, so 3 squared is 9, so it's going to be on the bottom. And the x plus 1 has a negative, so it's going to be on the bottom. So I'm going to go through. I know you can't see that. That's okay. That's going to be the final answer. So notice that the 3 cubed, it's negative. It's a 9. It's on the bottom. Oops. That's what I wanted. The 3 cubed is on the bottom. The x plus 1 is on the bottom. And the 2 cubed is on top. So there you go. I did it a little differently typed, but it can be done either way. It's the same type of thinking. Okay, so let's condense these. I want you to try condensing these on your own. So let's go over these. We're going to look at them. So I have addition. So if I have addition, that means that I can multiply. So that's going to be ln of 3x when I condense. I have subtraction for number 2. That means I can divide. So I have ln of x over 2 because 2 is being subtracted, so it's in the denominator. Number 3, I have 2 times ln of x, so I can take that number in front and make it into an exponent. So that gives me ln of x squared. So a couple things are going on for number 4. First, I have a number in front. So I want to move that number in front and make it into a power. So that's the first thing I'm going to do. So I have ln of 5 plus ln of 3 squared. So now that I made that number in front and made it into a power, now I have addition, and therefore I can condense by multiplication. So that's going to be ln of 5 times 3 squared. Well, now I could just do the arithmetic here. 3 squared is 9. 9 times 5 is 45. So that really gives me ln of 45. Number 5. Number 5, I have some additions and subtractions. Remember, anything that is added goes on top. Anything that's subtracted is going on bottom. So I can do this all in one step. So I have ln, x is positive, so it goes on top. 3 is positive, it goes on top. Y is positive, it goes on top. But the 5 is negative, so it goes on the bottom. That's all there is to it. Now, number 6, it might look difficult the way it is, but remember, you have something on the outside, so that means it's going to be a power, but it's the whole thing. So we're going to do that last. Let's do the what's on the inside first. Remember, anything that's positive is on top, anything that's negative is on the bottom. So let's write that first. So ln, I have a big fraction. So I have x squared plus 1 is positive, it goes on top. I have x plus 1, negative, it goes in the bottom. X minus 1 also goes in the bottom. Now I can deal with that 3 halves out front. That just means that this whole thing is raised to the 3 halves power. All that means. See, pretty much one big step. Now, these two problems are going to use the change base theorem. See, your calculator cannot do log base 5 of 89. All it can do is base 10 and base e. So I have to use the change base theorem. So I'm actually doing this both ways. So here I have log base 5 of 89. So I have log of 89. So this is log base 10 of 89 over log 5. If I put that in the calculator, log 89 over log 5, I get that answer. I can also do it with natural log of 89 over natural log of 5. I get the exact same answer. The change base theorem, it doesn't matter what you're changing to, okay? So both the log base 10 and natural log will give you the same answer because I'm changing the base, but it still gives the answer for log base 5 of 89. Same thing with the next problem. I do it both ways, log base 10. So log of square root of 5, so log base 10 is square root of 5, common log, and log square root of 2. Stick that in the calculator, and you get your answer. Now, something I do want to warn when you're putting these in your calculator, usually the top number will have an open parentheses. When you put this in the calculator, you'll type in ln, and then you'll see a parentheses. Then when you put square root of 5, you've got to close the parentheses. So make sure you close that parentheses. If you don't close it, then it's going to think you're doing the ln of square root of 5 divided by ln of square root of 2, the whole thing. So here, make sure you're just doing ln of square root of 5 divided by just the ln of square root of 2. So make sure you close parentheses. You got to do that, on all of them. So if you have parentheses in your calculator, just make sure to close them so you get the correct answer.